The first problem that we're going to solve are these two questions. First question is to determine the cutoff frequency for each circuit in each of the figures. And the second question asks us to determine the bandwidth of the circuit in figure 73. So in this, so to determine the cutoff frequency for a series RC circuit, we know that the cutoff frequency is given by 1 over 2 pi RC. So for this figure, for figure 73, it's easily solved by just plugging in the known quantities. So 3.9 kilo ohms for R and 0.039 microfarads for the capacitance. So FR is then equal to 1.05 kilohertz, or FC because this is the cutoff frequency, 1.05 kilohertz for the circuit in figure 73. For the circuit in figure 74, we have FC equal to 1 over 2 pi times 1 kilo ohm times 0.1 microfarad, and that will give us 1.59 kilo ohm as the cutoff frequency. What about the bandwidth for the circuit in figure 73? We know that this type of circuit is a low pass filter. Why? Because if we take the output voltage across the capacitor, then it produces an output voltage versus frequency response that is given by this, and somewhere here, which is 0.701, that corresponding to that value, we have the cutoff frequency. So in this is a low pass filter. So this circuit is a low pass filter. And we know that for a low pass filter, any signal between 0 and the cutoff frequency is allowed to pass, but all signals above the cutoff frequencies are not allowed. So in this case, the bandwidth is equal simply to the cutoff frequency, which is just 1.05 kilohertz. For figure 74, if you have a resistor, if the output voltage is taken across the resistor, then this acts as a high pass filter. And for a high pass filter, we have this type of frequency response. And in this case, anything above the cutoff frequency is allowed to pass, which means that since we don't know where or when or at what frequency this signal will die down, then essentially the bandwidth is infinite. So in this case, the bandwidth we can consider as infinite.